Okay, so on this one, I'm going to teach you about Pascal's triangle and the binomial expansion, kind of both at the same time. So let's start with Pascal's triangle. It's an interesting triangle. You've probably never heard it before, and you'll probably wonder why you're learning about it, but it's kind of an interesting triangle. Math people have studied for a while. There's lots of different uh, uses for it. But here's how it starts. It starts with a 1 right here at the very top of the triangle, and then it goes 1 and 1. Then it goes 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So I'd like you to stop for a moment and just see if you realize or think that you can see any patterns that are happening. Okay, there's some patterns going on, and it'd be great if you'd think for a minute about what these patterns are. I know some of you that doesn't sound very entertaining, but I'd like you to try to find some patterns that are happening. Just think about it. Okay, a lot of you probably saw this pattern happening right here. 1, 2, 3, 4, 5, and it also happens this way. 1, 2, 3, 4, 5, and it continues on that way. So 1, 6, 1, 6. Okay, so a lot of you have seen that pattern. So that's one pattern that you've probably seen. Okay, another pattern you see that there's all ones. But what about, how do I get the next numbers? I don't know if any of you saw this pattern, but look at this pattern. 1 plus 2 makes 3. 2 plus 1 makes 3. 1 plus 3 makes 4. 3 plus 3 makes 6. 3 plus 1 makes 4. 4 plus 1 makes 5. 4 plus 6 makes 10. 6 plus 4 is another 10. 4 plus 1 is 5. So anyways, that's how we're creating these patterns. So if I want to get the next row, I know that it's going to be 1 and 6 because I saw this pattern going on like this. Or I also could see that 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And then there's a 1. So this pattern will continue on, and you can keep going like this forever. Okay? So this is called Pascal's triangle. So that's Pascal's triangle. Now, we are going to use Pascal's triangle. Well, hold on. I'll show you how we're going to use it in a second. Right now, let's jump to binomial expansion. The two are actually tied together. Suppose I have x plus y. Okay? So I have two terms. That's binomial, two terms. And I have x plus y to the 0 power. Well, x plus y to the 0 power is 1, because anything to the 0 power is 1. X plus y to the 1 power, and I normally wouldn't write this, but I'm going to write it now just so you guys can maybe start to visualize it. 1x plus 1y. Okay? Now, this is going to be my work area over here. So now I have x plus y squared. So we've done this. Remember, x plus y squared is when I have x plus y times x plus y. So I have x plus y times x plus y. So I go x times x is x squared. X times y is xy. Y times x is yx or xy, if I put it in alphabetical order. And y times y is y squared. So that simplifies to be x squared plus 2xy plus y squared. So now over here, I'm going to write this down. equals 1 x squared plus 2 xy plus 1 y squared. So now the next one is x plus y cubed. So that means I really have 3 of them. So there's 2 of them, and now I'm going to put a third one on there. So that's this third. Now there's 3 of them. So I'm going to take the answer from these 2 and multiply it by x plus y. So x times x squared is x cubed. X times 2xy, well, x times the x makes an x squared, so it's 2x squared y, and x times y squared makes xy squared. Now I'm going to distribute the y, so y times x squared is x squared y. Y times 2xy makes 2xy squared. And y times y squared makes y cubed. So now if I add those together, I get x cubed plus 3x squared y plus 3xy squared plus y cubed. So over here, I'm going to write the coefficients down. 1, 3, 3, 1. 1, 3, 3, 1. So 1 x cubed plus 3x squared y plus 3xy squared plus y cubed. So I just wrote that down. So now if I go to the next step, x plus y to the 4th means that I'm going to take this and add another x plus y up here, so there's 4 of them. So really what I could do is I could take this answer, because that was 3 of them, and multiply it by x plus y. So now I distribute this x to all 4 of these blue terms. So x times x cubed makes x to the 4th. X times 3x squared y, well, the x's go up by 1. So 3x cubed y. X times 3xy squared, there's 1 x being multiplied to that, so that makes 2 of them. So 3x squared y squared, and x times y cubed makes xy cubed. So that was the x's being distributed to all 4 of those blue ones. Now we're going to distribute the y to all 4 of those blue ones. So y times x cubed makes x cubed y. Y times 3x squared y, well, y times y makes y squared, so that's 3x squared y squared. Y times 3xy squared makes 3xy cubed. Y times y cubed makes y to the 4th. So now, if I add those together, I'm going to get x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. So again, if I write that down over here, if I write down the coefficients, I have 1, then I have a 4, then I have a 6, a 4, and a 1. And it's x to the 4th plus x cubed y plus 6x squared y squared plus 4xy cubed plus 1y to the 4th. So if you're remembering the pattern, here's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Well, that is, what's happening is the coefficients, when we do this binomial expansion, there they are. 1, 4, 6, 4, 1, 1, 3, 3, 1, 1, 2, 1. So my next row is most likely going to be 1, 5, 10, 10, 5, 1. Well, let's try it and see if our conjecture is correct. Okay, so I am going to multiply this now by another x plus 1, or x plus y, because that's x plus y to the 5th. So see up here, I have 1, 2, 3, 4, 5 of them. So 4 of them multiplied together was this one. So I'm just going to multiply this times another x plus y. So I'm going to distribute that to all of those. So x times x to the fourth is x to the fifth. X times 4x cubed makes 4x to the fourth y. X times 6x squared y squared becomes 6x cubed y squared. X times this makes 4x squared y cubed. X times this one makes plus xy to the fourth. Now I'm going to distribute the y to all of those. So y times that is x fourth y. Y times this one is 4x cubed y squared. Now y times this one is plus 6x squared y cubed. Y times this one is 4xy to the fourth. And y times this is y to the fifth. So now if I add those all together, I get x to the fifth plus 5x fourth y plus 10x cubed y squared plus 4 and 6 make 10 of these creatures. 1 plus 4 makes 5 of those. And then we have y to the fifth. So again, if I write down the coefficients, 1, 5, 10, 10, 5, 1. So 1, 5, 10, 10, 5, 1. And now I write down the variables that were with them. X to the fifth plus x to the fourth y plus x cubed y squared plus x squared y cubed plus x y to the fourth plus y to the fifth. Now if you look at this, here's another interesting idea about this Pascal's triangle. Look at the variables on these. This is x to the 1, 2, 3, 4, 5. And same thing over here, y to the 1, 2, 3, 4, 5. So it's the same as that power. Now if I look at the middle of this, 2 plus 2 is 4 on those powers. 3 plus 1 is 4. 1 plus 3 is 4. So every term on this expansion, if I add the powers together, will be the same as whatever it is I'm expanding. So that's 4 of these ones. Since that's a 5, these are all going to add up to be 5. So 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, and there's 5. So on this one, with the 3, they're all going to be 3. There's a 3, 2 plus 1 is 3, 1 plus 2 is 3, and 3. So all of the powers will be the same as this power on the term, like the power that we're expanding. So if it's cubed, squared, whatever. Okay, so anyways, that's an introduction of binomial expansion, and it ties together the Pascal's triangle. So anyways, that's the first notes on this kind of stuff.